the back? Excellent. So, one of the things I really enjoy doing every now and then is going into Google and typing in stuff like computers will never be able to, or computers cannot. I like it because it's like tapping into the collective subconscious, our consciousness, I don't know, of what people think about what computers can and cannot do. And it's really interesting because you see, even despite all the really tremendous progress in computer science recently, there are still many areas that people seem to consistently think that computers just will never be able to do. Like, computers will never have a sense of humor, computers will never be creative, or no, the new variant, maybe I should check this out, ChatGPT will never be creative. And I'm going to argue that as a computer scientist, those are the most interesting areas to do research in. First of all, because they're fascinating, but also because every time you make improvement to one of those soft concepts, it immediately translates to improvement in how we can communicate and work with computers and devices. Just think how your life would be slightly nicer if your phone had a sense of humor, or at least some personality, right? It would make life more exciting. And also there's the other direction. Hopefully, if we teach computers to do one of those things like humor and creativity, maybe it will teach us something back about cognition, about how people seem to be doing those super complex things relatively, well, it seems effortlessly. So today I'm going to give you kind of a double feature. I'm going to talk about two recent fun projects, one about cultural references and one about creativity. So far so good? Let's start with cultural references. So this one is called Catchphrase. It's a joint work with my student Nir. So suppose you're going into your favorite internet forum and you read this sentence, one does not simply install macOS. Okay, I get this. Then you read more sentences, like one does not simply buy one item at Costco. One does not simply walk up Everest, and you start thinking, well, maybe there's more to those sentences than meets the eye, right? It seems a bit weird. So there's actually plenty of sentences following those patterns. Anybody knows why? I guess you know why, right? At least some of you know why. There was a sentence in Lord of the Rings, one does not simply walk into Mordor, that kind of became a pattern. One does not simply, everything goes. So our goal in this project was saying, well, the internet is full of such pop culture references. I want to help kind of the proverbial Englishman in New York. Think about the foreign student or one who's just not familiar with pop culture. I want to help them automatically detect such reference to pop culture quotes. Okay, help them see what's hidden behind those kind of seemingly innocent texts. So it turns out there's a word for this phenomena. Like everywhere, somebody called it snow clones. In 2004, those are phrasal templates that are easily reusable in many different contexts. And you all know those, like X is the new Y or X considered harmful. So it may seem similar in spirit to clichés, idioms and such things, but it's actually a lot more interesting because clichés and idioms have much more limited variation, right? You can say jump the shark, jumping the shark, but you'll never say he jumped the zebra, right? It just doesn't work. And those snow clones, they can really change domain to pretty much everything. One way I like to think about it is lots of people work on paraphrase detection, like finding when two people say the same thing in very different words. This is kind of taking this problem and flipping it on its head. They actually say some of the structure of the sentence remains, but the actual content can completely change. With me? Okay. So here's the first thing we tried. We tried treating snow clones as regular expressions. If you don't know what regular expressions are, this just means to X or not to X. We're going to need a bigger X, okay? Just some of the words you can change with whatever. And that makes sense, right, as our first attempt, because that's the classical view of snow clones. There's even a website called the Snow Clone Dataset, and this is their representation, to X or not to X, and then they go on and give you some examples of how to use this snow clone. So we phrase the problem pretty simply. You have a sentence, and you try to decide for each word whether it should be replaced by a wildcard. Okay, one does not simply walk into Mordor because one does not simply blanks. So the first thing we said before we even tried tackling with this, with machine learning and all the fun stuff, is this task even well defined? Can people do this? Right? Because that's something that happens to me a lot when I talk about those soft concepts. You're like, it's not even clear that those patterns exist or that they are agreed upon, or if I give this sentence to three of you, you'll say the same thing. So we ran a really quick user study. We to see if people do share this intrinsic notion of those patterns. We had 20 volunteers. We showed them pop culture quotes like 40 is the new 30, and we told them to tell us which words should turn into wildcards between 1 and 3 options. Okay, however many they felt were appropriate. We measured both how much they agreed exactly and how much they agreed on average, okay, percentage-wise. I'm going through this quickly because it's not really interesting. The fun part is that there were some personal preferences. Some people tended to go more general, some people tended to go more specific, but overall the results were encouraging. Okay, it seems to be there's enough signal to motivate the use of machine learning. So I said, okay, we can do machine learning. First thing we need to do is we need to get data. We went to the snow clones data set, like I said, to X or not to X. We treated those as patterns. We searched the internet or specifically Reddit forums for instances of those patterns. We ended up with 7,700 such curves of pattern and instance. Then we ran machine learning and we got relatively nice results. If you look at accuracy, if you look at recall, it seems those are good numbers. But then we actually tried using our algorithm on actual Reddit data. We tried to run, like I said at the beginning, we want to help the foreigner read a page of text and try to understand whether there are hidden cultural references. And then we figured out that our formulation, the regular expressions, might have been too simplistic. Because first of all, some sentences that follow the pattern are not actually referenced. Okay, consider the sentence from Apocalypse Now. I love the smell of napalm in the morning. So most people would agree that the right snow clone is something like, I love the smell of blank in the morning. And it makes sense, right? If I say, oh, I just love the smell of bureaucracy in the morning, I'm probably making a reference to this movie. But if I say, I love the smell of coffee in the morning, I don't know, I might actually like the smell of coffee in the morning, like some people are weird. No, I'm sorry, I hate coffee. Switch it with pancakes or something. And the other way this formulation is a bit too simplistic is that some references do not quite follow a pattern, but people understand that they do. For example, the pattern is X is the new Y, but you see stuff like 40 is the old 30, not 40 is the new 30, 40 is the old 30, and people still get it. So you say, okay, back to the drawing board, and now we treated this grounds classification. So instead of just trying to understand which words should be switched by anything by a wildcard, now we said there's a sentence, and there's a candidate, and we want to understand whether the candidate is a reference to the sentence. So we needed new data for this, and he was kind of working really hard on this. He got some famous movie quotes, defined very general patterns, collected a lot of stuff, and then there was a pretty painful annotation effort. Ended up in 3,800 pairs of seed reference and seed non-reference. And the main idea of the model was actually to use what we had in the first attempt, the regular expression. So what we were actually fitting the classifier is the original quote, our best guess of the snow clone, the wildcard form, and the sentence. And now we can compute all kinds of interesting things, like the words that do appear there, the words that remain, the words that are different, how close are they to the original one, how close are they to the snow clone form, and so on. Long story short, we actually ran Roberta and Dirk models on this new task. Really nice numbers, accuracy, precision, recall. But we wanted to see, again, whether it actually works for our use case. So Nir built an entire web extension that basically reads the page that you're reading and tries to find matches to, again, pop culture quotes, those snow clones, and then highlight them for you. So I don't know if you can read it, it's a bit small, but this person at the top says, TV should never be in the corner. And this person replies, nobody puts TV in corners. Anybody knows what this is a reference to? Yes! Okay, good. So if you hover over this, or an extension actually tells you this might be a reference to nobody puts baby in a corner from Dirty Dancing. And we ran another study with this extension. We had 10 volunteers that self-identified as not really great with pop culture, not native speakers. And we showed them some threads containing pop culture references, and we asked them, whenever you see something that might be a reference, point it out and also tell us where it's from if you know. So this is when they were not using the extension, and they managed to recognize about 40% of those references, and out of those 40, they managed to identify 60% of them, which is, by the way, interesting, because it means they can identify that something looks like a cultural reference, even if they don't know where it's from. But with the extension numbers are much nicer, 70% recognition, and when they recognize it, 98% where they knew were. By the way, this number is annoying. It's just people sometimes got the right answer from the algorithm, but they refuse to believe it, so the numbers dropped a bit. But we gave the right thing. So, long story short, the model does seem to help those people understand where pop culture references are coming from. Okay, this was the first half. Breathe in, breathe out, I promise 2 projects. Second one is actually the biggest project out of my lab right now. It's called Accelerating Innovations for Analogy Mining. This is about creativity. And the idea is that analogies have been a driving force of innovation for centuries. Okay, where ideas from one domain are used to solve a problem in another. The ancient Greeks looked at water waves to understand sound waves. Salvador Luria got a Nobel Prize for an analogy he made between slot machines and bacterial mutation. NASA hires origami experts to help them design folding spacecraft, which you should really drop everything and go check out if you haven't. Those are super cool. And my favorite recent example is something called the Odon device. Now the Odon device is this device that is used to help babies stuck in the birth canal. But the great thing about this was designed by a car mechanic in Argentina after he watched a really stupid YouTube video with a party trick, how to extract a cork from a wine bottle. And it's the same idea, and it can help save millions of lives, especially in developing countries, just because he watched this stupid video. So my point is that the web is full of innovation or of inspiration, just like YouTube. We have millions of patents, of scientific publications, crowdsourced innovation websites like Kickstarter, Innocentive, OpenIDEA, and all of this is a really great opportunity to find analogies to accelerate this process of discovery. Having said that, it's also a major cognitive bottleneck, right? Because nobody can be expected to be familiar with 10 million patents. So the initial question is, how can we help, right? How can computers help us go through those natural language, messy repositories and find analogies, find inspiration for solving problems? Okay, so after I told you how analogies are amazing, let me just tune it down a bit. So analogies have been a holy grail of AI for really long time. Okay, Douglas Hofstadter, the guy who wrote Geder Escher Bach. If you're a computer science student and you haven't read it, go check it out. And he wrote an entire book about it, a long book, saying that analogy making is a central mechanism upon which basically all human thinking rests, that we make analogies all the time, really all the time, yet still AI has no clue how to solve this. And for a really long time, this entire field of computational analogy relied on handcrafted data sets with really high relational structure. Okay, this is what, I probably can't read it, but this is what it looks like for how the solar system works. So we have sentences like revolve